Okay, here we are. Unit 3, Practice Test Answer Key. Alright. It's important that you as young mathematicians understand what types of problems we're working on. We're looking for quadratic expressions. Those are the ones in the form of ax squared plus bx plus c. It can be equal to something, but an expression is with no equal sign, just a mathematical statement. So I'm looking at this and I see the x squared. I see an x and I see a number, so I'm just going to rewrite this as 6x squared minus 13x minus 5. So this is a quadratic, alright? This one here is also, I just need to multiply this by itself and get 4x squared minus 3x, and I can do plus 0 if I need. A would be 4, B would be negative 3, and C would be 0. So this also is a quadratic. So I can maybe circle the ones that are quadratic. This one I'm going to have to FOIL. I do this and I get 2x squared, and then I do the rainbow, and that's a plus 14 minus 1 plus 13x, and then finally minus 7, and this also is a quadratic. Quadratics have a 2 right there and nothing bigger, but without a 2 it's just linear. This one right here is a cubic, so that's the big no, not a quadratic. Alright? Now on down to the factoring. When you're told to factor, that's all you need to do is factor. You do not need to solve it. There's no equal sign. There's no solution. I've got a minus sign there. I've got no coefficient. I know it's going to be x and x. The minus tells me something is plus and something is minus. I'm looking for two numbers that are going to multiply to make 4 that add up to make negative 3. So negative 4 times a positive 1, multiply to make negative 4, add up to make negative 3. You can always check these by foiling out carefully and you should get a good answer. Alright, this one again, it's easy to factor just straight up. You're going to put an x and an x. This is a plus sign, so it's going to be both, whatever that sign is. That sign happens to be a plus, so I make them both pluses. If that was a minus, they'd both be minus. I'm looking for two numbers now that multiply to make 50, that add up to make 15. That's a 5 and a 10. There should be some easy ones like this in the test. Make sure you get those. They're the easy layups. This one is a little bit more difficult because with 6, I don't know if it's 2x times a 3x or a 1x times a 6x. 21 could be 1 and 21, or it could be 3 and 7, and I could do all these different, it'd be like 8 or 9 different things. Some of you guys are good at this, but I like using the box method. So 6x squared goes there, then minus 21 goes there. Don't miss any minus signs. Don't forget to multiply. When you do that multiplication diagonally, you get minus 20 times 6 would be 120, so it's 126x squared. You write the same thing right there. That's the next step. Minus 126x squared. I now make a little factor tree with 126, taking out the even numbers first. That's 63. I can't take out a 2, but I can take out a 3 and 21. I can't take out a 2, of course. Once you can't do it once, you can't do it another time, but I can take out another 3 and a 7, and you always wind up with the hockey stick. That can help you do your factoring. You don't have to do it, but I'm going to have 1 and 126, and 2 and 63, and then 3 and, well then I just take out 1, 3, and I multiply whatever's left over. 21 times 2 is 42, and then 4 I can't do, but 6 I can. 2 times 3 makes 6 and 21, and I'm looking for numbers that, because that's a minus sign, will subtract and give me 5. Alright, I'm not there yet, so I've got a 9. Oh, I can do 7 and 18, and then I can do 9 times 14, and that is my difference of 5. So I write 14x there. I could write 9x, it doesn't matter, because but one of them has to be negative, and the bigger number gets the negative sign, so that's a negative 14. And then basically just circle that and then throw out common things. I've got an x and I've got a 2 in both of those. By throw out I mean divide. So I divide 6 by 2, I get 3. Divide x squared by x, I get x. Divide negative 14 by 2, I get minus 7. Divide x and it goes away. This is one of my two factors. My other factor will be something that makes my original problem right here, 6x squared. The only way to multiply 3x by something to get 6x squared is if it's 2x. I also need the negative 21. The only way to multiply by negative 7 and get a negative 21 is if I do a plus 3. That is now the factor. I might just copy it on my test over here so the teacher can see it. 3x minus 7 and 2x plus 3. Okay? So I'm going to do this one super fast. 18x squared plus 8. Multiply and I get 80 plus 64, 144. X squared, that's plus, so it goes 144x squared. And then I'm going to start my factoring. I'm not going to do the factor tree just to save time, but it's 1 and 144, 2 and 72. 3 does not go in. Oh, it does. 3 does go in, and it's what, 48? Oh my goodness, 3 and 48 make 51. There we are, 3x and 48x. Circle this again. I throw out common terms. I can throw out a 3 and an x. I will get over here 6x plus 1. And then what's going to make 18x is a 3x. What's going to make 1 times 8. And I've got it factored, and I'm done. There's the answer for that one and the answer for that one. All right, done with page 1. These we're told are difference of two squares. I won't be telling you on the test. You just need to know that if you see a perfect square there, x, and a perfect square there and a subtraction, difference means subtraction, I can factor this pretty much automatically by just taking the square root of this and doing plus and then minus, or minus and then plus. Foil it out and you'll see that the rainbow bits always cancel and you wind up with just what you want. So here I can factor this really easily, x plus 1 and x minus 1. Here we're told that these are perfect squares. I give you an example. These are in the form where it's something times itself, and I'm looking for a number that multiplies to make 25, that doubles to make 10, and that's going to be 5, x plus 5. So these are easy. I hope they're easy anyway. Again, you can do these old school method, just go x, and look at that plus. It's going to be both whatever that sign is, minus and minus. Two numbers that multiply to make 100 that add up to make 20, that's going to be 10 and 10. But I want you to write the answer in exponential form like this, okay? These guys we did in class. I'm giving you the form here, but you're not going to have that on the test. You look at this. This is your vertex. So it plugs into vertex form. With that is the x coordinate. Here it's positive 3. So I do y equals, and then it's going to be x minus 3, because that'll give me the positive 3. And then this, there's no adjustment. It's just straight like it appears, negative 5. Now, is there a number there? Well, if there was, I'd be going over 1 and up 1, and it would work out. But I can also just take and use the fact that this point here is 0, 4. When I plug in 0, I should get 4. If I plug in 0 there, whoops, don't forget the squared there. If I plug in 0, that's minus 3 times itself is a plus 9. 9 minus 5 is 4, and I should get 4. So I do not need to fill that in. That's an invisible 1. This one, this point here is also 0, 4. Here's the vertex. So I have it minus 1 and 6. So I'm going to do y equals x minus a minus 1 is plus 1, and then plus 6. But look at it, opens down. So I know it's going to be minus, but what I can do quite easily is just leave that as a, and I'm going to substitute in for y, 4, and then I'll have a times, sub in for 0 for x, I'm just subbing in the x, and then the y coordinate for this particular point that I know works in this equation, and I have 0 plus 1 squared. Oh my goodness, it's the second time I've forgotten the square. Don't you guys do it. Catch your mistakes like I just did. And then plus 6, and I work it out. These are all numbers with the exception of that one letter there. So 4 equals, well, what's 1 squared? It's 1. That's just a then. Plus 6. If I subtract 6 from both sides, I get a equals negative 2. So this is negative 2 right there. And this is the equation. That is the equation that if I typed it into my calculator, I would get those. And you can always check that on your calculator. There's nothing wrong with that.